Greetings, folks. Welcome. Have you ever heard the phrase good manufacturing jobs? Well, if you've ever listened to elected officials talk about economic development, then you've probably heard them express a desire for more good manufacturing jobs. And there's certainly something behind this fascination with manufacturing. Many manufacturing plants are large employers, so a new manufacturing business coming to an area is a tangible sign of economic development. And it can even give an elected official a ribbon-cutting ceremony to show that they're doing something to help the local economy. Also, at one time, manufacturing accounted for well over one-third of U.S. jobs, and manufacturing jobs are reasonably high-paying. Finally, manufacturing businesses are part of a region's economic base, in that they attract money from outside the area. The money that comes from the sales of manufactured goods to other regions has a multiplier effect in the region where the manufacturing firm is located, in that these dollars can be used to purchase locally provided goods, such as restaurant meals and even haircuts. Although there are certainly good reasons why many regions are looking to support and attract manufacturing businesses, this interest is tempered by the fact that manufacturing employment has been declining in the United States in many regions. Manufacturing accounted for 38% of U.S. employment way back in 1944, but this percentage fell to 16% of U.S. employment in 1990. By 2015, manufacturing made up less than 9% of U.S. employment. There are several reasons behind this decline in the share of U.S. employment accounted for by manufacturing, such as labor-saving technologies that allow companies to make the same amount or even more of a manufactured good with fewer workers, and the effects of foreign competition. Let's take a deep dive into U.S. manufacturing to get a better sense of its patterns of location and its effects on the economic development of U.S. regions. For this task, we'll use location quotients, which provide an indication of the extent to which a region specializes in a given sector of the economy. If a place has a relatively higher percentage of its overall economic activity devoted to a good or service relative to the benchmark economy, then the region is said to have a specialization in that good or service. The formula for calculating a location quotient is to calculate the ratio of an industry's percentage of total employment in the region you're studying relative to, or divided by, the industry's percentage of total employment in a benchmark economy, which is what you select for comparison purposes. The most common benchmark used to calculate location quotients for U.S. metros and states is the overall U.S. economy. Although I show the equation for location quotients using employment data, you can also use data on the number of business establishments. When interpreting location quotients, a value that exceeds 1 tells us that the region specializes in the industry. A value of less than 1 tells us that the industry is underrepresented in the region, and a value of exactly 1 tells us that the industry shares are similar between the region and the benchmark economy. Although a location quotient tells us the extent to which a specific region specializes in a given sector of the economy, you can compare location quotients across regions to figure out the extent to which the sector is geographically concentrated, just say in just a few places, versus spread out across the entire country. You just have to make sure that when you compare the location quotients across regions, you are dealing with the same industry. If an industry has location quotients that are reasonably close to 1 in all regions, this tells us that businesses in the sector are spread out evenly across places in proportion to the overall amount of economic activity. This is what you'd expect for a sector such as gas stations. Of course, big places like Houston and Los Angeles have more gas stations than small places, but the percentage of a region's total employment or total number of businesses counted for by gas stations is pretty similar across regions. This would give location quotients of close to 1 for gas stations in most all regions, telling us that they're evenly spread out. On the other hand, if an industry has a few regions with very high location quotients, and the rest are pretty close to 0, then the sector is geographically concentrated in those few places. If you went to an extreme where one region has a large location quotient in a sector, and the rest of the regions have location quotients of 0 in that same sector, then you have a case where the sector is operating in only one region of the country. That's the very definition of a high geographic concentration of industry. Here's a figure where I highlight the location quotients of U.S. states in the textile mill products industry. you'll notice that a few regions, so mostly southern states such as North Carolina, South Carolina, Georgia, and Alabama, have high location quotients, which suggests that these places specialize in textiles. Most states, however, have location quotients of close to zero, which suggests that they are what we call underrepresented in the industry. This is a sign that the textile mill products industry has a high geographic concentration of industry. Now, let's look at the location patterns of textile plants for U.S. metropolitan areas. Here's a list of the U.S. metros with the highest location quotients for textiles as of 2015. The percentage of total businesses in Dalton that are textile plants is 34 times higher than the percentage of all U.S. businesses that are textile plants. That's a very, very, very high specialization in Dalton. The location quotient for textiles exceeds 10, of course, in Dalton, but also Burlington, North Carolina, Spartanburg, South Carolina, Hickory, North Carolina, and Rome, Georgia. To move from using location quotients to measure industry specialization in regions to analysis of the geographic concentration of an industry, let's think about the percentage of total U.S. industry activity that is accounted for by the places with the highest location quotient. In textiles, you have Dalton, Georgia, which has the highest location quotient, and this metro accounts for 1.4% of the textile establishments in all U.S. metropolitan areas. But Dalton, Georgia only accounts for 0.04% of all establishments in U.S. metros. So Dalton accounts for a much higher percentage of textile plants than it does for overall economic activity. Burlington, North Carolina, which has the second highest location quotient, also accounts for 1.4% of the textile establishments in U.S. metropolitan areas, but Burlington only accounts for 0.05% of all establishments in U.S. metros. So just like Dalton, Burlington accounts for a much higher percentage of textile plants than it does for overall economic activity. If you look at both of these metropolitan areas combined, they account for about 3% of the textile plants across U.S. metros, but only 0.09% of all establishments. If we did the same calculations we performed for Dalton and Burlington for all U.S. metros, we could make a figure that shows the geographic concentration of textile establishments across all U.S. metropolitan areas. This is shown by the curved line in the figure. On the y-axis, which is up and down, we can plot the cumulative share of textile plants. Recall that Dalton accounted for 1.4% of the textile establishments, and then Dalton and Burlington together accounted for a cumulative 3% of all textile businesses. If you add Spartanburg, which has the third highest location quotient to the mix, the cumulative share would go up, and finally, if you added all of the metropolitan areas to the analysis, you would reach a cumulative share of 100%. On the x-axis, which is horizontal or side to side, we can plot the cumulative share of all establishments. Recall that Dalton accounted for 0.04% of all establishments, and then Dalton and Burlington together accounted for a cumulative 0.09% of all businesses. If you add Spartanburg, which has the third highest location quotient to the mix, the cumulative share would go up even more. And then finally, if you added all the metropolitan areas to the analysis, you would reach a cumulative share of 100%. As I mentioned a moment ago, the curved line in the figure represents the geographic concentration of textile establishments across U.S. metropolitan areas. And when calculating the cumulative shares of textile plants in total establishments, we do it in order by descending location quotients. That's why we did Dalton first and then Burlington. And the figure shows a reasonably high level of geographic concentration for textiles. If you move out to 10% for the cumulative share of total establishments, it lines up with about 40% of the textile plants. In other words, metropolitan areas that account for only 10% of all businesses across U.S. metros account for 40% of the textile plants. That's big. The straight line in the figure, which is a 45-degree line, is a good frame of reference because you'd have this line if textile plants were spread evenly across metros in proportion to all establishments. In other words, along the 45-degree line, the places that account for 10% of all establishments would account for 10% of the textile plants. And then 20% of all establishments would account for 20% of textile plants, etc. For industries that are found just about everywhere, these would be sectors like gas stations and retail stores, the actual curve for the sector would be very close to a 45-degree line. To take this figure and convert it into a number, we calculate the area below the curve and above the 45-degree line. In this case, the area is about 0.19. And this value is referred to as the locational Gini coefficient. It's called a locational Gini coefficient because just like a Gini coefficient measures the distribution of income and income inequality, the locational Gini measures the distribution of an industry across places. If we were looking at a sector like gas stations or retail stores that are located in roughly even proportions just about everywhere, the curve would be very close to the 45-degree line, and the locational Gini coefficient would be much smaller. In a book titled Geography and Trade, Paul Krugman calculated locational Gini coefficients for all manufacturing sectors using state-level data. Krugman found high levels of geographic concentration for all types of manufacturing, just like we saw for textiles across U.S. metropolitan areas. In Krugman's analysis, the most geographically concentrated types of manufacturing were reclaimed rubber, boot and shoe cut stock and findings, leather gloves and mittens, synthetic weaving goods, and fur goods. I think it's pretty clear that manufacturing sectors have high levels of geographic concentration. In other words, if you look at a specific manufacturing industry, it could be textiles or making leather gloves and mittens, you have a location pattern where a few regions have a lot of activity and most other places have close to no activity in the sector. So this raises the question of whether the places that have specializations in manufacturing perform better for economic development. That is, did a specialization in manufacturing way back in 1990 contribute to the growth of good jobs moving forward? Here's a look at the now familiar figure showing the relationship between the economic development of states. Of course, the Economic Development Index is made up of the employment, income, and persistence indices, and specialization in textile mill products. Although the trend line is downward sloping, the relationship is not statistically significant, so I show it as a dashed line. Without a statistically significant relationship, we say that a state's specialization in textiles did not affect overall economic development one way or another. I did a similar analysis for 19 other types of manufacturing for a total of 20 manufacturing sectors. In the analysis of states, specialization had no impact for 12 manufacturing sectors, like we found for textiles, and a negative impact for 8. The results for U.S. metropolitan areas were largely similar. So we started this video with the observation that state and local elected officials are almost universal in their pursuit of good manufacturing jobs, but yet we found mostly bad news in our analysis of manufacturing. First, manufacturing employment has declined nationally over time, from 38% of U.S. employment in 1944 to just 9% in 2015. Second, places that specialized in manufacturing in 1990 fared no better, and in some cases worse, in the growth of good jobs. We found this for states and metropolitan areas. But these 2 points are balanced against the reality that if a region is able to get a new manufacturing plant, it can provide a lot of reasonably high-paying jobs. And as it turns out, a growing manufacturing sector is good for economic development. Here's a scatter plot that shows the relationship between the economic development of U.S. metros and the percentage change in manufacturing employment from 1990 to 2014. You'll notice that most of the red dots that represent different metropolitan areas are on the left side of the figure, where employment growth rates were negative. In other words, these places lost manufacturing employment over the period. But the trend line is upward sloping, and it's shown as a solid line to indicate a statistically significant relationship. This suggests that getting new manufacturing plants is good for the economic development of regions. But if we're going to look at the relationship between economic development and the growth of manufacturing jobs, we need to do the same thing for non-manufacturing. In this scatter plot, we see a cluster of points that line up with about 50% growth in non-manufacturing employment from 1990 to 2014. That's quite different than the scatter plot for manufacturing employment, where most U.S. metros saw a decline. The upward sloping trend line, and it's solid, indicating a statistically significant relationship, tells us that the growth of non-manufacturing jobs help the economic development of regions. And this should come as no surprise, given that we define economic development as the growth of good jobs in a region to improve the economic well-being of people and the places where they reside. So in effect, these last two figures tell us that, indeed, growth of manufacturing or non-manufacturing jobs is an ingredient to the economic development of regions. So I think we learned that, just as it is in the study of lots of aspects of economic development, the impact of manufacturing on regions is complex. First, we learned that manufacturing sectors are geographically concentrated, and manufacturing overall experienced steep employment declines in the United States. Second, we learned that having a specialization in manufacturing, back in 1990, did not help in the growth of good jobs. We found this for states and metropolitan areas. But these 2 points are balanced against the fact that an increasing manufacturing, just like increases in non-manufacturing jobs, helps a region in the pursuit of economic development.